thanks everyone for coming to the BoF. This is a continuation of the previous BoF we did a few months ago in Las Vegas. I just took the same slides I had last time and I updated them to include what people told me they did and what they did not do. Assuming people told me what they did, which half people didn't tell me they did anything. So I have just a breakdown of the agenda, which is pretty much just these are the list of slides we have, the topics that I had last time, and then also just a general how things are going kind of question. So I don't really want to stand up here and talk. This is supposed to be a BoF. I'm not providing a status update. So yeah, we really should get a bunch of microphones and just let people kind of talk about certain topics they want to talk about. So I'll probably just stand over here off the stage. Really mess up the recording system. But yeah, so I can't even read it because my screen shows my body. So this is the first slide, which is just the baseboard stuff. So people, I don't know if you've seen on the list, but like, for example, sock info is being sent, and then also PIL is being worked on. This is the two things that this team inside Qualcomm was actually managing. And then the thing they told me they have not even started working on is SSR, which is restarting remote processors. So do you want to talk about this at all? Okay, great. Everything is done on this slide. Except for sock info, of course, is not done. Do you want to talk about sock info? Is Rob Herring here, who attacked sock info recently? No, he's not here.
No, I don't want to talk. So Venus is still in progress, but we have the MDT loader in place now, so it should be possible to get that stuff in order. And secure processor, we still haven't seen that one. And when it comes to SSR, in 4.11 we have everything in place, so when one remote proc dies, it will be restarted and all the devices associated with that will be brought up again. What we don't have is sysmon, so there is no communication between there is no notification to the other remote procs that a remote proc has died, which means, for example, when there are relationships between ADSP and modem, the modem won't know that the audio paths are gone and need to be reset up. Yeah, so the individual SSR is in place, but not system-wide. And modem in 996 is still in review.
Status update, great, good.
I did want to chat about sock info really quick.
Sure.
I didn't read the whole thread, but I did see Rob's comments. They were basically, there should be a generic mechanism with only some SoC-specific extensions where needed. So if that's going to be the case, I mean, who else has interest in this feature? I mean, who else would use it?
As I promised Rob to answer his email, there is a generic mechanism for the attributes that are documented. They doesn't really make sense in the Qualcomm world. So we have tried to map Qualcomm attributes to those things, and then we have added a bunch of things. I think we're more or less happy with the list of things that is there.
So the generic device abstraction provides a set of 3 or 4 properties which can be matched by kernel and user space. You can add additional attributes in there which will be available to user space but not to in-kernel users. So a kernel user cannot say, I want to match against this random attribute that only exists on this one sock.
And that's a good thing.
Yes.
Because we don't want driver writers to do that.
Mm-hmm. Yeah.
But it seems like Rob is saying, well, I don't want to speak for Rob, but reading his email makes it sound like he doesn't want anything to be there in sock info, or in the SoC node. directory in SysFS. So the 4 attributes, fine, sure, those have already been accepted, but it looks like Rob is trying to mac any additions that are not generic. So I need to talk to Rob. Or I probably both need to talk to Rob.
I tend to lean to the same thing. Usually, everything we need fits into them, and we can always add things to the generic abstraction if there's something. I think the serial number came up, and the build date came up recently as things that are generally useful that others could have, but then there are things that only make sense on one SOC and can try to put to I mean, they're all strings, so you can work things into the revision or the one of the other fields.
So I talked to Imran, and I wonder if maybe half the things that he put in there should just be put in debugfs, because no one really cares in user space to make an ABI.
Put into where?
In debugfs.
Yes.
I mean, why not, right? If we don't really care, if we're just using it for debugging anyway, then really there's no point in making user space API and SysFS out of it.
Right. So the SOC device abstraction is mainly used so that you can have an application that knows about 20 different SOCs and can match them and do things differently based on one of them. But if you go beyond that, it's not really the perfect abstraction for that.
So I don't think debugfs is going to work, at least for us internally. There are applications, for better or worse, that look at these fields to determine, various parameters about the system. And Google going forward is basically mandating that debugfs is off on their Android builds for things. Yeah. So I mean, we'll need. So at least for our internal stuff, we'll need to, have some other extensions or some other non-debugfs. Yeah, that's fine.
Then it means we have to push, right, to figure out what things in here actually matter for whatever user space program we're using, which I don't know what they are.
Yeah.
But if it's all of them, that's really bad, right?
It shouldn't be too much, but the stuff tends to creep. But it sounds like we can give some clear direction to Imram what to do then. Well, yeah, that's the direction, is to go figure out each one and then.
But I mean, that's the whole point I said, please write a document for documentation, because if we didn't do that, no one would have noticed. It would have made this crazy API. And people would have probably got pissed off at us later. But that's fine. So I guess we need to talk to Rob this week about this. And also then continue the discussion on the mailing list. To go for another 15 rounds or something. Is my screen turned on?
Who's going to talk to Rob then? Steve or Bjorn, one of you guys? Or Jendra? You'll talk to him? Okay.
Okay. This is just the order I had previously, so I don't even know. I got nothing for SMMU or memory management. So I just said everything is still to do. Does anyone want to talk about any of these topics?
Rajendra or Chit, you guys want to chime in?
Well, for SMMU, we need to figure out. So the thing, the way the SMMU is integrated on Qualcomm SOCs is not how it is expected to be in the upstream driver. So we have SoCs which have multiple TBU instances and one TCU, and these TBU instances might be tied to a particular power domain. So we probably need to split out the driver a bit, and the ARM guys probably would need to be okay with that. So we'll probably talk a bit with the ARM guys. And Rob, do you want to add anything?
Well, I mean, I was kind of hoping to find some ARM guys here this week, because there's a few different things I need to get people to actually look at the patches and comment. But yeah, I mean, there's two different I mean, there's two different IOMMU drivers in the end. I mean, there's ARM SMMU for I don't know, the newer beef family stuff. And then I ended up having to write a new IOMMU driver for the older stuff where we can't touch the global register space, and the secure world sets everything up for you. I don't know, I hope someone comments on them sometimes. I mean, there are a few other things I want for like the GPU side, like stalling support if we had hit a fault. And that's, at this point, mainly for debugging. I'd like to be able to dump out GPU state when there's fault before we resume the GPU. I think eventually we'll want that also for SVM sort of stuff, so that we can not have to keep pages pinned. For example, if you do like if you're mapping user malloc to memory to the GPU, I mean, that will build on the stalling support, because the tricky thing if you're doing things like that is you need to, I mean, the IOMMU fault handler ends up getting called from an IRQ context, so you can't call into MM code or anything that needs a mutex, so you actually need to be able to toss handling of the fault off to a work queue, for example, and then at some point later call back to IOMMU driver to resume. I did send some patches for a proposed interface changes to the IOMMU to handle that, I don't know, a month back or something, and that was another thing that I haven't heard any response from the ARM guys on. But yeah, I don't know. I don't really have much more to say than that.
You want to talk about the ion stuff?
There's a whole separate ION BoF on Friday.
So we'll just talk about it on Friday?
Yeah, we'll just punt it.
Sounds great. Let's do it. Let's not talk about it now.
So on the ion stuff, I think Daniel Vetter was even interested in, you know, once I think, I haven't followed it too closely, but I mean, ditching custom ioctals. I think Laura already ditched the cache stuff.
Yeah, this is my old slides from 6 months ago, right? So I think half of the stuff she knacked in Las Vegas.
Yeah.
Or more.
But yeah, I think we're going to drop custom ioctals or maybe clean up some of the ioctal stuff. But I mean, Daniel, once that's done, Daniel was even willing to take that via the DRM tree if we have to.
Hopefully the ion BoF is much better next time, or on Friday. We'll know more details.
Yeah, it's kind of too bad Laura's not here. I don't know if, what time of the day is it? Maybe she can join. Okay, that's not the ideal time.
Another 10 a.m. BoF or something? Great.
Yeah,
Let's do it.
if it yeah, okay, that's unfortunate.
Okay. The power stuff, I didn't get an update either. I think everything is the same. Nothing has changed. Anybody want to talk about anything about power? I know that, is buskilling on here? George is going to talk about buskilling later today, right?
Yeah, random thing, not really Qualcomm specific, but with the power domain and runtime PM, it'd be kind of nice to be able to decouple the power domain and the clocks. Like on the GPU, if I turn the power domain off, I have to reboot the GPU when I come back, versus if just turning off the clocks, I can get going quicker. So that's
This is you want like a light sleep or a light idle for your device, right?
Right.
Yeah.
So
I don't know what happened to that series for the multiple levels of power domains. It actually never got merged, right? Multiple levels for power domain. Yeah, performance levels. That's not merged, right?
So yeah, Beresh is working on that. It's still ongoing. There was some comment, but I think that we should find a solution or an agreement soon. I mean, there is no real objection, just about defining how we really want to describe this state.
Resh's thing is performance levels. This is like idle levels, just slightly different, but related.
But I think for the kind of scaling Qualcomm does, I think there'll be other hardware blocks that'll want to do the same thing once they're in power domains. Like the
Right, as long as we have some kind of like generic level API, then we can start adding like, I'm GPU and I want to turn off my clocks but leave on my power domain, and then I'm GPU and I want to turn off clocks and power domain, or I want to lower my clock rate, or I want to max out my clock rate. Like these should all be levels, right, or something in power management world
So is
that
there
GPU driver can use.
a patch set for this out there, or is this something we need to plumb in when the time comes?
This is like embryonic stage, I think, for different pieces. But like only Resh's thing is only for, my understanding is only for the corner stuff, not to do with this kind of like device-specific driver wants to control a particular knob here and there to control a different piece of the powers. Like it would only control the corner and not turn off clocks and leave on power domain, for example,
Is this
which
the
should
kind-
have to be added, and just no one's done yet.
Is this the kind of thing that Linaro's power management group should help out on, or is it?
I don't know.
Can you just, on which part?
Which part do you mean? I think he's talking about the combining a generic way for a device driver to hit some particular power state for its device. No, I don't know if the device tree is related to this at all. I don't really care.
I think the support for power domains to support multiple states is already in, and all we probably need to do is to handle clocks along with GDSEs in our power driver, and then the drivers can put in QoS requests saying my latency shouldn't be more than so much, and then the power domain driver can then decide what would be the state ideal, like just cut off the clocks and not the power domain.
Okay. Yeah, you're
And
most
so on.
talking about idle state.
Yeah, yeah.
Okay.
I
Does-
think- yeah,
Only
that's,
for idle state, yes, everything is over.
yeah, everything is already there. What we need is for our GDSE driver to also handle clocks. And I think I proposed some patches a while back. The major concern there was how do we handle the case of config PM disabled, right? What do we do in case config PM is disabled? We just go through all these clocks, and then today they are mostly handled in drivers, and I guess with config PM disabled, we expect the power domains to be turned on by the bootloaders. So do we just expect the clocks also to be turned on by the bootloaders, or do we need to handle it in some way in the kernel? I think that's the only
Yeah, for the idle set, I think everything is available in the main line, just about using it in their implementation of power domain. The next step is more about what we call performance state or running state.
So okay, I probably haven't been following this topic so much, so maybe a dumb question, but are you talking about moving the clock set rate and clock enable and stuff into core? Okay, just the enable. Okay, that's probably okay.
So are we going to discuss about the performance state patches in a different slide, or do we talk about? Okay. So I just had a concern while I was trying to get those to work on Qualcomm platforms. The big limitation that I've been hitting is the fact that we cannot associate more than one power domain to a device. So it's quite often that you have multiple rails that you need to put performance state requests on. And if that's the case, then we need to be able to have drivers to be able to control more than one power domain.
Okay, and or maybe I can catch that on the mailing list, but why do you need several power domain?
So we have devices which have their logic and memory powered on through two different rails, right?
Oh, yeah.
And both of these are controlled by a microcontroller. So the drivers running on Linux basically communicate a performance state, a minimum performance state, a QoS request, right, saying we need to be operating at a certain performance level. So the performance level could vary for a memory rail as well as a logic rail. And
Yeah, I remember that there was a proposal to put
yes, there was a proposal.
param per domain below.
Yes, yes. So today we have, you can only associate one PM domain with a device, but a PM domain can have multiple parents.
Yeah.
So the patch was basically proposing to create a sort of a virtual PM domain for devices which have to control more than one power domain.
And that would be something, this solution would be okay for you, or?
I guess it would be, because we should, we would still be able to put QoS requests. Actually, I'm not sure if we would be able to. So the end requirement is to be able to put performance requests on individual rails, like we were just discussing on for the modem. We do request different performance states on these two rails. So I'm really not sure if the proposed patches from John Hunter would allow us to do that.
Yeah, but probably we need to continue the discussion on the mailing. But yeah, I would say it's ongoing.
Yeah, I'd say that's the big problem, though, because it seems like the generic power domains are considered to be like this is the platform glue for a particular thing that's in the domain to do whatever power management's related to that, and it's not actually what people in the embedded space think is a power domain, which is some kind of switch you can turn power on and off to a device. So there's like, people don't realize these are not the same, and it gets confused all the time, which is really the big problem that we have. We need to get over this, and pretty much need to have multiple power domains. None of this crazy stuff where you have a hierarchy of domains and virtual domains. It makes no sense. It's not what it is. It's not what it's in the hardware at all. But yeah, we should probably keep talking about this on the mailing list. Is there more stuff on power? We can go 6 out of 11.
So on CPU, maybe Georgi, you're working on for the CPU effect? No, nobody is working for the CPU effect part. I'm not sure. I'm still wondering. The 410C? Okay. And so you need something specific, if I remember correctly, from Las Vegas. You have a way to behave that is a bit special? Or for the A53?
Is this the safe parent thing? Is that what we're talking about? Switching the frequency of the CPU, and you need to switch it to a particular frequency that's not going to kill the clock while you reprogram the clock that the CPU is using. I assume that's what this is. We can have the...
So there was a proposal to create a new Kicker API for kicking remote processors. Because on Qualcomm platforms we have a register space which is used for various things, one of which is to trigger into remote processors. So it will be good to have such an API to...
So are we making this Kicker API, or does the winds change on this topic?
You proposed the bike shed, so how about...
Yeah, that's fine. I can build it. Well, George's going to do it. I love bike sheds. They're great. Okay, so I guess we're just... It should be pretty simple. Okay, well, that's fine. So I think we're just waiting for that. That's okay. Oh, no, I lost it again. Maybe I should plug in the power so it stops turning off. Okay. Okay, this is Peripherals. Vivek is not here, but Vivek has been doing a lot of work on this, right? From USB and PCIe, but not really UFS. I think no UFS work from him. The UFS I think has been kind of going on. It's been the same story from the same team for UFS for a while. I don't think anything's changed there. It works, right? Okay, yeah, I had some note in my notes that the binding is still bad. I don't think they fixed the binding still. Right, I think Vivek is going to fix all that. At least that sounds like the plan. Right, so the PHY driver seems to be stuck on the fact that we want all these generic properties instead of the magic sequence to program the PHY initialization sequence from device tree, right? So we're basically stuck on device tree review for that one. It's cool. So I guess.
But I think it's only the PHY maintainer who thinks that's a good idea. So
To put it into the C code.
The PHY maintainer doesn't want it in the code. It
Oh,
wants
yeah,
the
yeah, yeah.
table in device
Yeah.
tree.
Not table, the generic bindings to describe how the program goes.
Yeah, so the list of registered writes that we need to do when initializing the PHY, he wanted that basically just moved into DT. And I made the counter argument, and then there was some internal soul searching at Qualcomm, and that came back to we don't really know what these parameters are, or we can't express them in a human readable way, so let's have it in the C code. And then Kiran, I think, the PHY maintainer, have not responded to that yet. So
Yeah, I haven't heard anything internally about this topic in over a month. So I
I think
assume
the
nothing happened.
QMP driver is good, and I've been running it for weeks now on my 820 board.
So the only problem then is that this is sometimes like a board-specific configuration sequence.
Yes, that for each platform we need to add that chunk of register rights or chunk
Yeah,
of
yeah.
registers and values to the driver, and maintainer doesn't really want that in C code.
Right.
Except that we definitely don't want it in DT.
Sounds like we're stuck. Great.
Maybe we can pay Rob to say that he doesn't want it in DT.
Okay.
It's exactly the same case as the side panel drivers.
Which also do these kind of fine initializations, but the number of registers in our case is probably so huge that you need to maintain these big tables in the driver. Yeah, that's what I guess we were trying to do, but it turned out that nobody really, these are a bunch of registers that you get from the hardware team, and you just, do these one-time writes, and then.
It seems to be one per platform.
I don't know if they still do. I remember the downstream kernel had tables in device tree, and then they started adding, entries for doing delays and things like that. You invent a whole language in device tree.
That's.
Can you treat it as firmware?
Like to request firmware.
Can you treat it as firmware? I don't know if that helps. I mean, the thing is, like, I don't know what happens, like, okay, if it's just a list of writes, okay, that's kind of address data, but then what happens, like, if you need to, like, teach it how to poll until some bit flips in a register, or things like that, and then you start inventing a language.
And the answer we got from Qualcomm was that the list of either registers or values will only ever change if they figure out that they made something wrong on, for example, 8996, in which case all versions of that driver, or all future versions of the kernel should have that fix. So we should only have one set of these rights coming per platform. No. So that's why it makes even more sense to just put it in the driver and have a compatible, which is already platform specific, select that sequence and be done with it.
Yep. So having a file driver that knows about how to set things up for different scenarios is great. Having a file driver per board is insane.
So it's a PHY driver that have a few different, or will have a few different compatibles, one per platform.
What is the platform in this?
So it's 8996 or 8998.
An
or
SoC
whatever.
model.
Yes, or it's less than the number of SoC models, depending on your definition of model.
I thought it was still some kind of board difference as well, because like they had to do some kind of drive strength difference or something.
Yeah, but that's okay. That's what a driver is for. Then you have a device tree property that says the drive strength on this should be this much.
Right, but
the driver knows how to turn that into register values. That's what a driver does.
I don't disagree, but I'm saying that the inside, no one knows what those things are.
Yeah, well, then you can have a table. I mean, you add a table. Like if the drive strength is this much, those are the register values. Now, if we need another board that has a value that we haven't needed before, then we add the driver. But any other board that will need the same value will have the same register values.
My understanding is that the way it works is that the hardware designer tells people what the value should be, including the customers who make the boards with the SoCs.
Then we should integrate the hardware design and the driver, right?
Yeah, I mean, that's pretty much what's happened, right? And so we somehow need to figure out how to tell the hardware designers to start telling us what actually changed, and then have us describe it in device tree. But then, I mean, that's just like a legal quagmire at that point. So I don't even want to step in there, which I think is why we've given up. But it's definitely not per SoC. It's definitely per board, and so that's the problem, right? Is that it's a combinatorial explosion, and what's with that? Keep adding more and more compatibles. For this is 8996 on board XYZ, right? And then the driver code will have that. I don't know.
Because we haven't seen it so far.
I mean, we only have Qualcomm reference designs, which probably all follows the same stringent requirements, and then no one knows that something has to change, right? I don't know about some random phone that someone made that needs some different values.
Yeah, but even if we figure out that we need different tables, it's going to be, well, especially if there's a lot of values, it's going to be odd to have that as a table of magic values in DT.
I don't disagree. I'm just saying that this is
maybe we can look at the board-specific stuff and make a comparison with the generic register values and figure something out.
So do we actually know what the registers are called? Do we have no?
I probably can't tell you, so I don't know. They're probably called like register 1, 2, 3.
Yeah.
That's most likely what it is.
Well, we do that for wireless cards. That, as Nico suggested, for wireless cards, there's a lot of tuning going on. Every instance of a wireless module needs some special magic put in there, and we treat that as a firmware file where we load it from disk or from device tree.
But this is the disk, so you would end up having a firmware blob that you compile into your kernel versus having some sort of data structure in the kernel already.
Yeah, we'll just have to put the right firmware blob into the right kernel for that particular device, right? I mean,
the one difference is that another board can add another firmware file that they can include in my kernel without changing the C code. Changing the C code means I'm changing the object code of the kernel, whereas adding a new board that needs a slightly different set of register values would mean I have a new file that gets added to the CPIO in RD and then loaded from there.
how is this better than device tree? I just want to play devil's advocate, right? I mean,
No,
it's almost the same.
It's the same. You could do it either in device tree or in the in a file, we would just call it a firmware file that can come from one or the other. It would be
Sure.
like a
So then we should just add
string.
request firmware support from device tree, right? And then we can just put it in device tree as this is a firmware blob 2. And then request
I
firmware.
think we've already done that in some.
Awesome. So then we should just do that. And then we can put it in device tree again, and then everybody wins. Except for Bjorn.
Or we just put it in the driver. That leaves the door open for it being moved into a firmware file later, because we won't have a ABI difference.
Yeah, that sounds fine too.
So.
Then we have 2 ways of getting it. I mean, the driver is always the last resort, right? You can always just override with that and not request firmware. So I don't think it really matters, but okay. At least we have a plan.
Yeah, when it comes to PCIe, it's I think the only part left there is the GDSC clocks relationship thingy.
Yeah, the power management one. I didn't put any left to do on this one, so I don't think I know much details. But yeah, the PHY driver is pretty much done, right? The PHY is done
Oh,
for PCIe.
well, pending this discussion
Yeah.
of where the register values go.
Okay. I'll move on to the next one. Display.
So we got the DT bindings in, which is not mentioned here. So at least for DB410C, we don't need any additional patches to get display up.
That was to fix the GPU binding?
So the GPU bindings are still pending. Rob's
Okay.
working on that.
I don't have a GPU slide after this one, by the way.
Okay. Okay.
So there's one thing, well, one main thing missing still. We wanted to convert over to the OPP bindings for the GPU scaling, but if it's missing that node in DT, it just falls back to a safe clock speed. So I think we can start getting the DT nodes in and then add the OPP tables later. Hopefully that's okay.
So the write back feature, it's something that's common across other SoCs too, and some guys from ARM posted out an RFC to add the write back feature to DRM core. So that's going to take a while, but I think we can just use that. Should work.
The kind of tricky thing is there's kind of 2 use cases for write back. One is if you're doing like the wireless display sort of use case where you're just streaming it out. And I think there's pretty much consensus we should expose that through V4L. The other use case is like a one-shot thing. Like if you're using the write back to composite multiple layers and rotate, and then you want to trigger scan out. I think there was the idea, so like with the atomic support, everything's now a property and we can kind of, it's extensible and add new properties. So the idea was to add a write back frame buffer property, like say to the CRTC. It's kind of hand wavy. Someone needs to write proposals and then bike shed and repeat a few times and then.
Yeah, I think for brightness control, someone again has proposed an API, right? I think Intel.
I mean, what actually is needed there beyond the backlight interface? I mean, are you talking about something like CABAC or?
Yeah, like we have an additional like apical IP which like maintains a histogram and it kind of like changes the final color colors to,
Okay, but doing it in the display controller block instead of in the panel?
yeah.
Okay. Yeah, I mean, I think it's the same we can implement at the backlight interface, but yeah.
Are there any concerns here?
No, it's fine. I think, I mean, HTTP 1.4 is something we were wondering if Linaro, I mean, since it's a common problem and everyone's doing it downstream and they don't really care about upstreaming it at all. So might be a thing that Linaro might be interested in implementing as a feature.
That's to Brian.
I was just going to ask, where would that fall within Linaro, as part of kernel consolidation or the home group or something?
Eventually, the home group. I mean, if you want to showcase Opti like a secure video playback, it would be nice if there are less patches downstream for HTCP.
Okay. Maybe I'll talk to Mark about it then.
Okay.
Thanks.
Next slide is GPU, I think. Yeah. I got this information from Jordan, who's been doing the upstreaming for this part. He just gave me what he did and what's been done. I don't know if you want to talk anything about this.
Yeah, yeah, I'm not sure how much he has done and is waiting to get approval to send out in some cases.
Yeah, I think some of these things are still to do. He said I think like per process page tables. I think he already has it all written. He's just waiting to send it.
Yeah, he did send some patches for the multiple ring buffers bit. I think the AMD guys pointed out that they had some code in their driver which was kind of generic-ish, and maybe we could reuse. I'm not sure how far along Jordan is with that. But yeah, it seems like he's got multiple patch sets that he's waiting for permission to send out. Okay. Yeah.
Is there anything that you think Linaro needs to be working on here, or this is all fine? We keep doing it the way we're doing it.
I'm not sure. I haven't. I mean, there's a whole lot more to do in user space. Okay.
Yeah. I think we're pretty much done. The next 3 slides are very small, from what I recall. Oh, video. I have no information on video. Does anybody want to talk about this one? I know the video jar has been going on. This is probably inaccurate.
Okay. So, yeah, the patch settings on the Linux media mainly. So we reach version 6, and probably I will send version 7. I have acknowledged for device rebinding. Also, we have a solution for firmware welding. Yeah. And the other one is the firmware. So we are still waiting the permission to redistribute the firmware.
Okay.
Yeah, so the big thing holding us back here is the release of the firmware. That's going through processes now, and so should be able to get that out in the relatively near future, and then that would unblock the driver to move forward. Well, it only took like 6 months.
Why do we need to wait for the firmware before the driver can get up?
I said we are already using DMA BoF, so that's there.
Yeah, it's completely inaccurate. I think what still to do is a mistake
Yeah.
on the slide.
I don't know if anyone from V4L has looked at the fence FD stuff, but that would be probably a nice next step. But, I mean, that's kind of a generic thing, and maybe that's something Linaro could work on. Oh yeah.
Okay, I'll just move on. Networking? I didn't hear anything about networking. Nothing's happened.
For Las Vegas, we're still holding off on IPA.
Yeah, I think we told the IPA guys after Las Vegas, right, that we should never upstream it, and I think they stopped asking questions about if they can upstream.
Well, I think you wanted to send me.
It's not never, but it's that's going to be really hard. Yeah. So it wasn't like never try this. It was more like if you've got somebody who really knows what they're doing, you could go for it, but don't just like randomly try and upstream it without understanding why that might be a problem.
Maybe we can slightly change the messaging to them. But I don't think they're going to upstream it anyway.
No.
Okay. We'll tell them to have a sliver of hope, is that what you're saying? Great. I have audio, but I think audio is also inaccurate. I have no idea what's going on with audio. Just you want to talk about this?
So, latest status on audio is on 410C mainline we have analog and digital audio working with DSP bypass. But on the latest chips, it's difficult to actually bypass the DSP. So we started putting efforts to get the DSP audio working on mainline-based kernels. So I started looking at it, and as of today, I have code which works on 410 or 411 based kernels on both A and B family, which is basically just digital audio. But we are looking forward to upstream this stuff in future, and I think very soon. I'm actively looking at this at the moment. At least the DSP-based LPAS, APR, and the ASM, ADM stuff. It's been on the plate for a long time, and yeah. Well, yeah. 2 years ago. Yes. 2 years ago. Yeah.
I think they're looking at it now as well, and I don't want there to be any disconnect.
Yeah. Okay.
They're looking at it, and I'm going to ask them to do all that stuff. So it should hook them up with the stream.
They're not currently concretely sending patches.
No, they're not acting.
No.
Nothing's.
I mean, did they at least completely try to revise an iOS in such a way that they could send patches?
Yeah, I mean, they've been active in this area for a while. I mean, Patrick is designed to be more or less compliant.
So, I mean, it needs to be measured. It's been false.
Yeah, it's not a, yeah, we started looking at it seriously. That's what this, yeah. And yeah, we have ambition of upstreaming that. That's the.
And there are many pieces that you just remote from iOS. So iOS is there. We can move to the next steps.
So the downstream driver is around 70,000 lines of code. So yeah, so there's a lot of modules just other than what we have listed here. So.
Mark, since you're here, any progress on SoundWire?
No.
Do you need Sunbuzz right now?
Yeah, yeah.
Are you using? Oh, you're using it, right? You must be using it now.
Bus for unlock audio, yeah.
Okay.
Yes, Sagar did send a couple of iterations of the patch last year. I stopped doing that again. So there were some really comments from Mark, and then it stopped. The ball stopped rolling.
Right. Okay.
Yeah, I have one quick question. I think I heard somewhere in the conversation today that the MIPI display timings have moved into the device tree. Did I hear that, or did I mishear what you said? That's what they do downstream.
Yeah, we don't want to do that.
Sitting on Qualcomm device, or Qualcomm development network on how to set MIPI device timings, and it sounds like it's changed, so we need to update the app note or the user experience so that people generating or using new MIPI displays will know how to set up the timings.
So you're talking about like the 5-bit?
So basically the MIPI display, you know, you've got vertical sync, horizontal sync times, number of active pixels, those things.
Yeah, but those are all panel specific.
Yeah, they're all panel specific, I agree with that. But where are the values held?
Yeah, so for the upstream kernel, we don't really want to put those in device tree. There's actually a DRM panel abstraction. So we have a couple panel drivers upstream, like I think one of the Sony panels, a few others. There's a simple panel driver for things that are real, where you literally just have to set the timings. For other things where there's like a panel programming sequence to power on, that we want the code. I do have a wiki page somewhere that gives a basic idea of how to translate the downstream big table of numbers into code. Right.
I just want to update my app note to reflect the current phase of setting the DSI timings.
Okay. Remind me, and I'll send you a link to the wiki page. That's right. Right.
Yeah, I know it's going to be two cases. The way it used to be done today is done now. And split the document into two paths, or read the path.
Right.
It's done in the add new section.
Right. I mean, I think the wiki page has some Sony specifics, but it should be. I mean, a few people have looked at that, and panel drivers have popped out. So I guess it's enough to to figure it out.
I just don't want to point my users to bad information.
Sure. Yeah. Yeah. Remind me when I have my laptop in front of me, and I'll send you a link.
Any other comments, questions? All right. Thanks, everybody. Appreciate your attendance and participation.